Start with our session. Last session we started to explore the new learning paradigm, which is reinforcement learning. First time we had explore about that what type of problems we can say that this classify under the reinforcement learning. Because till date we are having supervised and supervised problem. Now unsupervised learning. Now we are exploring the reinforcement learning. Last time even we had seen the example of the how you can learn to drive the bicycle. I think there we don't have any standard procedure how to drive the bicycle, and if we talk about reinforcement learning, I mean we don't have any prescribed procedure to learn the cycle, or somebody didn't tell me that I need to apply this much amount of this much newton of pressure on my pedal and I need to twist my cycle 3 degrees on right hand side to maintain my center of gravity, right? So basically what are the components we talk about the and we are having it. These are the two major components of your reinforcement paradigm. So how they basically interact? So learn from the interaction. Region will interact with your environment. Environment is a bicycle. If you are playing chessboard, your opponent is in your environment. Your chessboard is your environment. If you are seeing any drone or helicopter, you are want to fly in the sky without crashing down. Yes, to learn from the close interaction with the environment. What do you mean by environment at that moment? Environment is either your basically either you want to reach helicopter or your chessboard. This all are your close interaction with your agent will going to interact with your environment. So what do you mean by environment? You need to understand, right? This is your stochastic environment. Stochastic, why? Because it's been probabilistic. The involvement of the probability is there, that's why we are telling this one stochastic environment. Here we are doing scalar evaluation. What do you mean by scalar evaluation? What are the reward we are getting? Because every time, whenever reinforcement learning things come in mind, people think about this two words. Reward and penalty, right? Scalar evaluation, we are converting the value on the scale. If you had a knowledge about cost function optimization and the artificial neural network, this seems like that. If we are telling that here we are having scalar evaluation, if we are having vector evaluation, then we will need to think that which vector direction has dominance, and we need to find it out that the domination or variance that vector and find it, and then we need to optimize this thing. This will be a simple value that on scale. So simple optimization you can use over here. If it is in place of scalar has been vector, then it's been very complex to optimize it. That's why I just need to understand exactly, and if we can draw out the figure that exactly we can understand environment, agent, this direction, this loss of the action, you can change the state, and you are having evaluation. Now simply understand that super learning problem, you generating the error, that's your evaluation parameter. If the error is 0, you almost reach whatever the things you had desired, right? But over here, we don't have any solution. We just having evaluation thing. If we think about that, if I'm playing any game, if I'm playing chess, I'm taking one step forward in whichever direction I want to take the step. Every time I seriously cannot generate the reward mechanism. If chess and on the board, every step cannot generate reward. Ideally, this is for our convenience. We generate this mathematical reward function. But if you talk about any biological system or your human system, right? In biological system, you are having sensory input. Means if I am fallen down while learning the bicycle, my skin will give the information to my mind that I am having pain or I am hurt, or um, or we are having some optical, we are collide with some optical, or that portion of the body will indicate to the brain. Means in brain certain segments is there where they actually evaluate the things, right? Every time you didn't get the reward for it. You need to understand that thing. The reward is not possible in each and every thing. If I'm playing anything on a chess, after every step, we're not getting reward. Second thing, once you complete the game, getting +1, +3, or whatever values you associated, we are telling it in +1. And if you are losing or draw, will give you 0 as your reward value. Somebody will tell, sir, why cannot I use some other notation like that? +1 to when lose, we are having -1. Even we are having +1, 0.5, 0.25, 0.10. This makes making system very complex. This is only two values. As I said, +1 with minus. Means if we talk about it, if we are moving forward, we need to give reward 0.001. It seriously does not make sense. So we don't want to provide such system that eventually increase the complexity of the system. Because honestly, if you talk about any game, any such game, because now you need to understand it. Because my basic intention is to don't give you brief summary about reinforcement learning. My basic purpose to cover this topic is to get the awareness about what is reinforcement learning. How we can classify such problem as being reinforcement problem or not, or if some problem is there, can I model that problem to reinforcement? Because itself, if you people give me just a second, please hold. Hello. जल्दी बोलो, लेक्चर चल रहा है. अब कहाँ से बात करें वो पहले होता होगा और कहाँ पे एडमिशन लिया था. I had left Parul before 6 months. Parul before 6 months. Okay. So this is my basic intention. Otherwise, you will give me 2 years, then also we can learn the reinforcement learning. This is completely new paradigm, and seriously, people are investing their massive amount of time over here. So I cannot make justice in 3, 4, 5 lecture. Even I cannot give the justice in complete 6 months over here. So now we are having agent. Please try to understand figures. So you might be getting some input you are giving to the agent. Why it's not supervised learning problem? That's we exactly understand over here. This is your output. Already have a target. And then we are calculating error back propagating to this. We are calculating the error, finding out the gradient, removing and negative gradient direction. So this is your supervised learning problem. So what here not present? no target had been provided to you guys. Right? Target is not there. How can you calculate the error? No error gradient is there. You're basically your action, whatever you're doing, is chooses your next state. So here we had drawn this action. Basically choose your next state. Here we are exploring to estimate. Estimate means here we are finding out the certain probability in trial and error fashion. In trial and error learning, we can say that. Right? So why not supervised learning? Because we don't have a target. If we don't have a target, we cannot find it out the error gradient. Your action specify which next stage you are going to go. And here we are basically doing the trial and error. If we talk about chessboard, it will be 8 cross 8, 64 blocks. We cannot write it. If we talk about tic-tac-toe, 9 blocks. This is your tic-tac-toe board. Now, how many steps we are taking as an individual? This is a two-player game, right? And if I want to train this game using your reinforcement learning, then how many steps basically one person can take? Can anybody tell how many steps? It's very simple because it's only had a 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. And where you need to take the steps means each player four moves. Your fifth move, it's being deterministic. This has been deterministic game. Either you're winning, losing, or you can say that the draw is possible over here. Right? Now, before this, starting to evaluate this game, why has been not unsupervised learning problem? That also we need to see. This is your agent. This is your agent again. This is your evaluation. This is your input. And this is whatever the underlying beat and the beat want to find. If we talk about unsupervised learning, they're basically working on it. Right? But here, the pattern discovery is not my binary objective. In basically unsupervised learning, we are doing just and finding underlying pattern because we don't have a label, right? And if we don't have a label, so at that moment of time, our basic thing is to find out the pattern, the underlying thing. But here again, we don't doing that thing. That's why it's not. And if we talk about now simple rules that can help to explain this complex behavior. एक मिनट चालू. Yes ma'am. 17 में 2021 ये 2021 for this complex behavior. Right. So now this means a series of operations. It's not like that if I'm playing the tic-tac-toe, I had having 4 complete moves. If I started with the board position 0, I'd put X over here, the opponent will put his O at certain place. I'm completely following this procedure from starting to ending. I'm doing the evaluation of it, means finding the probability, the chances of probability that I'm going to win the game, right? And I put my X at board position 0, and then after in second step I put my X at board position 5th, then I put my board position 7th, and so on, right? We will discuss about it, but if the intuition of this complex behavior is whatever the prediction we are doing of outcome at time t plus 1 is better than the prediction at time t. Whatever steps taking at you are taken at t steps, you are just put at your X at certain board position, right? And when you are taking next step t plus 1, it should be better than your t state. And it should not better than what we will do, we will think about it also. Hence, use the later prediction to adjust the earlier prediction. One good example I can generate it out. If somebody is playing the chess game with his opponent, and in current state, because he can kill the queen of the opponent, killing that. But it leads that board position seriously compromising his winning scenario, because he's in that position that somebody can seriously win the checkmate, because we focus on the queen, we didn't focus on winning the game. So if I'm killing the queen, after that whatever the state I'm achieving, that really shows that now my winning possibility of this game is only 0.2%. In a T state, I had already the probability of winning this game is 0.6%. So now I understand that in this state, because I'm the killing the queen, and because of that I'm in awkward position and I might not going to win this game. So I need to backtrack and going to time t, because I had already known the time t plus 1 state probability, that now how I can going to win it. If we understand this thing with tic-tac-toe, because if I put this, somebody's put this, putting this over here, right? Then somebody's put over here. Then if I'm putting my X over here, till this point I'm having 0.6% probability of winning this game. But after reaching this state, this is your T state. This is your T plus 1 state. Please try to correlate it, why I'm telling this. Then here the probability of the winning this game is 0.2. Here has been 0.6, right? Our preliminary thing is our need to understand, if I cannot win from this T plus 1 state to forward, So I need to decrease my probability of winning at node at state T. If I'm going backward, because I already explored the T plus 1 state, and I'm going backward and reduce this probability of 0.6 to reduce the probability of state T sorry because T plus 1 state the winning probability is 0.2, right? Because of this, we're going to reduce the probability of winning at T state from 0.6 to any such value, 0.4, 0.5, whatever value you are associated with. Just a second. Point 0.45 or 0.4. This is one move. If we had a game tree, if you had learned about a game tree, this is your tic-tac-toe. Somebody had moved over here. Means I can place my X if this has been step 1. This is very good thing you need to understand. I can place my X is over here. I can place my X at this place. I can place my X at this place. Third. Then this fourth place. This is fifth place. This is sixth place. This is 7. This is 8. This is 9. Right? Now each the state add branches. Now the opponent can place O in this 8 position. 8 different position. For over here, it means putting over 8 position. This. The complete path we are creating. But before that, we need to have one assumption. If we want to train our board for tic-tac-toe game and we are using reinforcement learning, right? We need imperfect opponent. Why imperfect opponent? I think tic-tac-toe game is that if you had an expert person in playing the game, then every time we are starting to draw if your opponent has been expert on it. So we need imperfect opponent to learn something, and reinforcement need to learn how to play this game, and eventually you need to be an expert of this game, right? So we exploring this branch first. You put your X. Now opponent will put 0. Might be over here. 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 Right, this is the 1, 2, 3, 4, 5, 6, 7, 8 possibility we are having for opponent who can place his O in this 8 position. Now we need to find out the evaluation for each and every state. This all path the simultaneously is going to explore. Please understand this in your game tree that you had learn in your alpha beta cutoff or something. Once you're calculating the probability. Similarly, you are calculating over here, 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 and here. Right? We are not giving reward, please understand, because you are putting 0 or x over here and you are getting reward. No, the reward will come at the end. If you are winning the game, you are getting +1. If you are losing the game, you are getting 0. This is your reward. But now we are taking evaluation of probability, that we are taken first step, then we are taken second step, third step, fourth step. Over here we are calculating the probability. Over here we are calculating the probability, which leads to winning the game. This complete sequence lead to winning the game. It's not only the one state going to lead the winning the game, right? So this is your t+1 state, and this is your t state. Over here, if you're taking the step, the chance of winning this game is 0.6. I'm just explaining whatever I had written over here. And not that much big iPad, so I can draw a complete tree. But this is 0.6, this probability. Right? Over here, I've taken some steps and my chance of winning after that I had evaluated this probability has been 0.2. Means winning this game from this node is seriously very difficult. So now I understand that my t+1 state is indicating that from here the chance of winning is very negligible. So what I will do, I will go in my previous state. From t+1 I will go to t state, means from 3 I will go to second state, and I will update the probability of winning over there. There we had a probability of winning is 0.6. So we are reducing because we are already seen the futuristic state, and now we need to come back and reduce that thing. First thing, this is for this position, board position. We are having simultaneous next 8 game trees. We are not affecting this game tree. We are just exploring this only and drawn only this thing. If you are taken, this is first step, this is your second step, assume that after that you are having third step, then fourth, fifth, and it leads to your winning or losing, right? But simultaneously for this all other state also you are preparing your game tree and you are calculating every time probability whenever you are moving to one state to another state. The probability of winning this game, please understand it, not probability of moving in right direction or not. I think one Hollywood movie is there, but I seriously don't know, but I will draw you the name of the movie. I will later on remember, and I will seriously ping you guys. If this is my tree, assume that I cannot draw tic-tac-toe, so I will draw this thing. Just a second. Hello? 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 वस्तु का नहीं पूछो, वस्तु का नहीं पूछो। तने नहीं बात कर तो 1 मिनट उभो रे भाई। अरे 1 मिनिट હું ફેકલ્ટી પૂછું છું, માં લેક્ચર બી ચાલે છે. 1 મિનિટ ઉભો રહી બેટા. વેબસાઈટ પર જવાનું એમાં. હા. જો આપણી ચારુસેટની વેબસાઈટ છે ને, એની અંદર સ્ટુડન્ટ કોર્નર છે, એની અંદર બસ સર્વિસીસ લખ્યું છે, એની અંદર બધાના નંબર આપ્યા છે. અને હું કોઈ બરોડા વાળાનો નંબર બી શોધું છું અને પછી તને મોકલીશ લેક્ચર પછી, બરાબર છે? કોઈ એક મેડમ બી આવે છે, એ બી બરોડાથી આવે છે, એમને બી પૂછી લઈશ એ જે ડ્રાઈવરનો નંબર હશે, કેમ કે આ સર્વિસીસ જે છે એ આપણી તો નહીં પણ કોન્ટ્રાક્ટ વાળી છે, તો એનો નંબર હરકો મળે તો આપણે ફાયદો છે, બરાબર? હું તને લેક્ચર પછી કરું. અરે વાંચું હું પહેલા તારું બસ થઈ જાય પછી થેન્ક યુ કહેવાનું, અત્યારે નહીં કહેવાનું. માં લેક્ચર ચાલે બરાબર બેટા, પછી કરો. So this is the tree. In every node have a certain probability. Here's been 0.8, 0.6, 0.7, 0.5. Here is been 0.45, 0.7, 0.8. Random values are there. Understand? Where all the values are generated. Every time, if I will take the best possible node, this is my next state. Every time I prefer this route, this, and then over here, sorry. Then here we are at 0.65, 0.55, 0.4. Again, I will take the maximum value in my next state. Again, I'm taking maximum value. Again, I'm taking maximum value. And I'm reaching to the solution and I'm winning the game. If every time I'm taking the next state as my best evaluation value, not probability value, then your system is not going to learn anything. Then your system is not going to learn anything. Why I'm talking about Hollywood movie? In that movie, the person is playing same game again and again. He's not learning anything. So I didn't remember the name of the movie, but it's honestly the thing. This is the tree. Every time I'm choosing my best node, I'm not learning anything. I'm not exploring any other nodes. This digit 2 is very, very simple. Only 8 move are there, 4 from each side, and 5th is deterministic move. Means either I'm winning or losing, right? But if we talk about chessboard, we are having 64 boxes, and if you want to generate 36, game is huge, honestly. And every time you are doing same and same move, you are not learning anything. Please understand this thing. That's why I'm giving the example of that Hollywood movie. Okay. Okay. And the lecture we next time explore this thing. Thank you.